Hi everyone. Let's continue with lesson 5, permutation and combinations. We've done permutation on first 4 lesson and now we're moving on to combinations. What's the difference between the two? They're related to each other, very similar. And let's look at the following example. As a grade 12 English course student are required to read the following 3 books and they can read in any order. So Steve can only sign out one English book at a time. So the question is, list all the different orders Steve could sign out the book. So it could sign out the grape, right, the wall, the beans, or like he can do it this way. He can do the walls first and then swap the other two, right? He can do this. He can read the bean trees first. So how many ways? The answer is 6 ways. You have 3 things, so you can just simply say the answer is 3 factorial, so it's 6. Now look at part B. Another student, he's allowed to sign out all 3 books at the same time. How many different ways can he sign out all 3 books? Well, if he can sign out all 3 books, there's only one way, which is all 3 books. Because for the second question, the order doesn't matter. So part A is an example for permutation question, which you have been working all along from lesson 1 to 4, in which the order is important. Different order, different arrangement is considered a different permutation that you count them separately. Then there's a permutation question. Whereas when the order is not important, you just want a collection of things. Doesn't matter what order they're put in, it just like how many ways you can like have this group of things or like this, then it's a combination question. Okay, so is it clear? It's all about the order. If the order matters, is permutation. If the order doesn't matter, is combination. So this is the statement. So um, as you see examples, right, you see more and more example, and then you will be able to tell, is it a permutation question or is it a combination question? And then you solve them accordingly. All right, suppose that the student in part 1 were required to read only 2 of the books. Complete the table to show the number of ways in which Steve and this guy could do this. All right, first he can do this. Grape, walls, grape, beans, wall, grape. So if we look at the way, it's 3 permutation 2. Because you have 3 books, you choose 2. So if you look at the formula, 3 factorial over 3 minus 2 factorial. You do the math, you still have 6 ways. So it didn't haven't finished listing all the one. You can have the wall and then the beans. You can have now do the beans, the grape, the beans, and wall. So there are 6 ways here. Now on this side, you can have grape, wall, and wall grape is the same combination. You can have grape and then beans. Finally, you can have beans and wall. So on this side, you have 3 ways. So 3 combination 2, right? You have 3 books. You just want to pick combination of any 2. Then what will be the answer? Right, in here you see the answer is 3. I'll show you the formula. You will figure out why. Okay, so I just want you to show you the difference. Same, like a similar question. You can have 3P2, 3 permutation 2, 3 books. You find the permutation of picking 2 of them when the order matters, right? Will be P. That will be the answer. The answer will be 6. Here, you have 3 books. You just need any combination of the 2. So there are total 3 different combinations. A combination number will always be less than the permutation number, as you can see, because for combination, the order doesn't matter. So for the same combination, you just count it once. But then for the same combination on the permutation side, you will count them as 2 because you can have grape and wall or wall and grape when you count the permutation. All right, complete the following statement. The number of combinations is equal to the number of permutation divided by 2, right? 6 and 3, so 2, or like 2 factorial. So we'll look at the formula in a minute. The permutation is an arrangement of element in which the order of arrangement is taken into account, whereas combination is a selection of element in which the order of selection is not taken into account. So again, just saying the same thing. And here just showing the reason why combination will be less than permutation. So I think I'll just give this example. They just want to explain that. So let's jump to the formulas here. So we skip a page to page 97. All right, the combination is the permutation number divided by r factorial. And since permutation is n factorial over n minus r factorial, now you just divide by another r factorial. So this will be your formula. Okay? All right, this formula is given. You just need to learn and use it. And then I can say there's another notation. This is one way n combination r. And now in some textbook, you can also write it this way. You have a big round bracket and then you put two numbers stacking to each other. So one thing is r is always less than or equal to n. All right. And also the combination number will always be less than or equal to the permutation number. It's usually mostly less than. They can be equal if they both equal to 1 in some cases. Okay, anyway. Well, let's look at some example. Then you know how to apply it. 3 students from a class of 10 to be chosen to go to a school trip. Okay, chosen. In how many ways can they be selected? Does the order matter here? You just want to pick 3 students from a group of 10. If I choose student ABC, is it the same selection of student CBA? Well, it is, right? So it's a combination question. So write the answer in factorial manner. Okay. Well, we can look at it this way. You have 10 students, right, to begin with. All right. You just want to choose 3. Now, if it's a permutation question, remember, this is how you do it. You have 3 spaces you want to pick. How many choices are there? There are 10 people, 10 choices. After you pick one, you're down to 9, down to 8, right? We did those questions in lesson 1. But here, the order matter because maybe you're choosing A, B, C, and then versus C, B, A, you count that as different. But now, from what we have learned last time, if the order doesn't matter, you just divide everything. There are three selection, right? So you just divide everything by 3 factorial. Then you get the right answer. Okay? So whatever that's equal to. Let me do the calculation. 1, 2, 0. 120 ways. Confirm the answer using this. You can also just write 10C3. To the formula, it will be 10 factorial, all right, over 10 minus 3 factorial. That's the formula, right? Like this part will be the permutation, which is this 10, 8, 7, 10, 9, 8. And then you divide further by 3 factorial, like which is this part. This 3 factorial is same as that. And then the other part is same as the 10 times 9 times 8. You put this in the calculator. In the calculator, there's a button for that. Just find it, right? P, and then I find the C button now in math, and then in probability, then you can find the C button, and then you enter 10 and 3, and then you will get the number. All right. Hello, hello, hello. Okay. All right, try another question. To win a Lotto 649, a student must correctly select 6 numbers between 1 to 49. And then he puts 6 number, and then the order doesn't matter because whatever number you pick, that's the number set that you have. So first ask yourself, is it a permutation or a combination question? So we figure out it's a combination. So therefore, there are 49 numbers. You just need to choose any 6 of them. And that will be the different number of selection that is possible. So you can put that in the calculator. Athletic Council decided to form a subcommittee. So whenever there's a committee question, if you just want to have a group of people, the order doesn't matter, right? A committee with ABC, same as committee with BCA. So order doesn't matter, so it's a combination question. A committee question is a combination question. unless in the committee they have some position, let's say president and vice president and treasurer, and then having A being president and B being vice president is different from having B being the president and A being the vice president. So if you have a committee, but then there are roles or like position, then it will become a permutation question. Okay, so hopefully you see the difference. So let's look at this. You want to form a subcommittee of 7 people, of 7 council members. Okay, you have 7 council members, you want to form a subcommittee. How big is the okay, you want to form a subcommittee of 7 people. There are total 15 people to choose from. This 9 of them are male, 6 of them are female. 9 plus 6 is 15. This is where the number comes from. The subcommittee must consist of exactly 3 female. Okay, well, let's look at this. Now, if it's just forming a 7 people subcommittee from 15 people with no restriction, it will just 15 people, you just choose 7. All right. But if there are restriction, well, let's look at this. You have a 7 people subcommittee. 3 of them must be female. Well, where does this 3 female you can choose from? Well, you can choose them among the 6 female. So instead of having 15 selection for the female, you only have 6 people. You choose 3 of them to form your 3 females. How about the remaining subcommittee? Well, there are 9 male. The remaining must be male, so which means there are 4 male. So you're choosing 4. And is your committee 3 female and 4 male, or you would say or 3 female or 4 males? Well, some committee have 7 people, so it's 3 females and 4 males. You remember whenever we say and, what do? We multiply them. So the answer will be, the final answer is multiply these two together. And you put it in a calculator, you get your answer. All right, so look at this. 6 and 9 is the total number of people. Hey, that's 15, right? But it's just more specific now, separating the male and female. And then the 4 and 3, right? 4 and 3 give you the 7. Because you're forming a 7 people subcommittee, that's why I add up to 7. But now again, you separate into 3 females and 4 male, just more specific. But I hope you get the idea, right? This one is for no restriction, just any 7 people from 15 people. Doesn't matter if they're all male or all female or any combination. But here you have some like requirement. Okay, so you just put in a calculator. In how many ways can the subcommittee be selected if Bruce must be included? Okay, well, which means you have 7 people, but one of them have to be Bruce. So for Bruce, there's no selection, right? So it has to be Bruce. So there's one Bruce, you have to choose that Bruce. So that one person, you choose that one person. This will just give you a 1, so it doesn't affect the number. The remaining 14 people, right, because Bruce is already chosen, you just need to choose the remaining 6 people. So the answer will be 14C6. The 1C1 is just equal to 1. And then you put that in your calculator, you get the answer. All right, let's see. Are there more examples? All right, let's try this one. Playing cards. All right, so see, it's important to play cards. A standard card of 52. Well, okay, it's the standard card, 52 cards. You just need to know the following information. There are 4 suits, so each one have 13 rank. There are blacks, black or white. There are face card, are Jack, Queen, King. So there are total 12 of them. Poker is a game that play from a deck. Okay, how many different 5-card poker hands are possible? Okay, so 52 cards. You just choose any 5 cards. That would be how many different possible hand. And then the combination doesn't matter because in your hand, you can just rearrange your cards. So the order doesn't matter. Now, how about if they're all diamonds? Well, out of the 52 cards, there's only 13 diamond. If you want to have a diamond flush, you have to choose all 5 cards, right, from the 13 diamond. 4 black and 1 red. There are 26 black, you choose 4. There are 26 red, you choose 1. Then that's your hand. Total together, you have a 5 cards hand. There are total 4 kings, you choose 3. There are total 4 queens, you choose 2. It's and, so it's always multiply. 3 kings. So 4 kings, you choose 3. Well, the remaining two cards can be anything from the remaining 48 cards you choose two. Okay, so I'm running out of time, so I will end here for this lesson. See you.